Hello mathematicians, we're now going to have a look at lines through the intersection of two given lines. So we know that if two lines cross, they have a point of intersection. We also know that there are a multitude of other lines which pass through that point. So we're going to have a look at problems where we want to find some particular other line that passes through those points. And it might be that that particular other line has to have a certain gradient, or it has to pass through not only this point but some other point, but there's some condition on it to separate it out from the literally infinite number of other lines that pass through this point of intersection. Now we could do this by methods that we already have. We could take these two lines, for example, solve them simultaneously, obtain the coordinates of that point, and then if the condition was that the line we wanted also had to pass through this other point, then if we've got 2 points, we can then get the gradient between these 2 points. We can use the point gradient formula and we can work it out from there. But there are alternatives, and the alternatives can often be quicker, and they certainly are elegant alternatives. And maths is all about being elegant, of course. So if we have two lines and they intersect at some point, then what we can say is that every line passing through that point M where they intersect has this layout. Now let's think about why that is. So if this line passes through point M, then M must satisfy it, which means that when we put the coordinates of M into here and into here, that equals 0. And when we put the coordinates of M into here and to here, that equals 0. Now, our new line has to also pass through this point, so it has to look like, when we put the coordinates of M into it, that it would equal 0. And this is one possible construction. There are lots of possible constructions, but this is one, and it's probably the simplest. So it's that I take one of the lines, and it doesn't matter which one, plus k, lots of the other line, and set that equal to 0. Because if I take my coordinates of M and I put them into here, this part will be 0. And when I put them into here, this part will be 0. And 0 plus k times 0 is 0. So this is a layout which somehow takes just the two equations of the line we've got and some constant which we don't yet know, and states that this new line must equal 0. Our task is then to build on that to solve whatever the question asks. So I'm sure you will need to spend some time thinking about that to get your head around it, and maybe it will become clearer after each example. So let's have a look at the method in practice. So our first example says we have these two lines here. I'm not even going to try to draw anything except that I've got two lines crossing over. They must have a point of intersection. Now, as I said before, we could find that point of intersection by solving simultaneously. We also have to pass through some other point, 2 minus 1. So with 2 points I could get the equation of the line. But I'm going to do it without actually finding this point just here, because I'm going to say, I might just change colours to emphasise this, I'm going to say there is only one other line that passes through those 2 points, and this is the line that we want. And because it passes through that point of intersection of these two lines here, then it has that layout. So this line here is of the form x plus 2y minus 6 plus k lots of the other line, 3x minus 2y minus 6, and that must equal 0. But not only is it of that form, but this point here must also satisfy this equation. So when I put 2 and minus 1 into this equation, the equation has to be true. So let's substitute that in. So when x equals 2, this is 2, plus 2 times y, so that's 2 times minus 1, minus 6, plus k times, and again, when x equals 2, that'll be 3 2s are 6. This will be minus 2 times minus 1, which is then plus 2, and minus 6. Gather stuff together, so 2 minus 2, so I've got minus 6 plus k times, in here I've got 8 minus 6, which is 2k. So the only value that k can have, so that that general equation of a line through here also passes through that, will occur when 2k equals 6, therefore k equals 3. So therefore the only line which satisfies this is the one where x plus 2y minus 6 plus 3 times 3x minus 2y minus 6 equals 0, which is, so I've got this x and another 9x's, so 10x. I've got this 2y and minus 6y, so that will be minus 4y. I've got this negative 6 and I've got negative 18, so that's minus 24 equals 0. And I could divide all of that through by 2. So this is the simplest equation which will pass through that point and also through that point. And if I was really unsure, if I was in an exam and I was unsure that I'd done the right thing, I could put that into here and see whether it makes it true. Yeah, and that's it. I've got a pretty good chance of it working then. Okay, so let's have a look at this next one. And again, what I hope you can do is say, this is my understanding, this is my understanding of the problem, how am I going to solve that problem? So there's a lot more thinking and maybe even less writing. So what we will do is, we know that two lines have to pass through the intersection, have to have an intersecting point, M, and we know how to get the equation of any line that passes through those two. It's going to have the layout of a line through M. Any line through M will be of the form of x plus 2y minus 6 plus k lots of 3x minus 2y minus 6 equals 0. So that's any line through those. Now, of all of those possible lines that pass through there, we want the one which has a gradient of 5. So we want the one line that has a gradient of 5. So we think about what it means to have a gradient of 5 and how that's related to this line here. And we can remember that if we write our line in point gradient form, gradient intercept form, y equals mx plus b, we can get m. Or if we just write it in standard form, we can get an expression for m. So let's take our line here and write it in standard form. So if we did that, what would we have? Well, we know we have to have x, and it gets multiplied by a coefficient. What's the coefficient? Well, it's 1 just here, and it's 3k from there. So 1 plus 3k. And we have to have some y's, and they're getting multiplied by a coefficient. So what's that? Well, there's 2 y's here, and there's minus 2k y's there. So 2 minus 2k. And we have to have some constant, well, we don't have to, but we could have some constants. So I've got minus 6 and minus 6k. So minus 6 minus 6k is the constant bit, and that would equal 0. So all I've done is rearrange this one, and I've put it into standard form. ax plus by plus c equals 0. Then I relate that to gradient. I know that the gradient of a line in standard form is minus minus a over b. So that will be minus 1 plus 3k divided by 2 minus 2k. And what do I know? I know that I want that gradient to equal 5. Having done all that, done all the thinking, now it's just calculating. So I go ahead and find what value of k makes this true. So my left-hand side here will be -1 minus 3k. When I take this up and multiply it by 5, that'll be 5 2s are 10 minus 10k. Gather terms, so if I bring this over to here, that will give me 7k's. And if I take that over there, that will give me 11. So k equals 11 on 7. Definitely not a nice number, but it's a number. So therefore my one equation, which will have a gradient of 5 and pass through this point of intersection, which we've never found, is just either this with the k in front of there being 11 on 7, or this with the value of k being 11 on 7 in there. Now it's up to you which you think is the easiest to work with. I would actually probably go up to the first one and just say x plus 2y minus 6 plus 11 over 7 times all of this has to equal 0. Multiply through by 7 to get rid of this horrible fraction. So I'd have 7x plus 14y minus 42 plus, now I've just got 11 times what's in the brackets, so that's 11 3's, 11 2's, 11 6's, and over here is still 0. And now gather terms together. So I've got 40 x's all together. I've got, what's that, minus 8 y's. And I've got minus 108. Is there anything which will go into all of that, which will simplify down? So 8 won't, but 4 will. So if I divide 4 into this, that will become 10x minus 2y, and this will go it'll go 27. So that's my equation that I want then. So have a go at 5f, the odds from 3 to 13, but do the thinking. That's more important than memorizing the method. Think about what the method is based upon, how it can be applied to the particular question, and go for it.